Hey folks, um, yeah, I was pretty sick. I got lots of colds and stuff, so I didn't really get a chance to um, talk out the process of what I was working on. But I know last time we left off on a general architecture of what we wanted to accomplish. Um, Let me see if I can pull that up. Okay, yeah, so I still have a little bit of cold, but anyway. Um, so last time we kind of left off, we are trying to figure out what the architecture was going to be, and I was trying to mention that we'd like to have as little centralized pieces as possible for a decentralized chat application. So uh, to start though, we can't really, uh, just to make our life a little bit easier, we have to have a little bit of centralized stuff just to kind of make progress. So what we currently have is centralized is Firebase, and we use it for authentication. And I'm going to go over a little bit about how we can, how actually the authentication works right now, and what approaches we may be able to take to avoid using Firebase. Second one is AWS, and we use it for hosting the application, the website, and also the APIs. And what else? Oh yeah, we have a DynamoDB that's storing the chat. It's basically facilitating the chat messaging back and forth. These are centralized, but to a large degree, hosting a website and the APIs, you do have to centralize it at some place, especially if you want to have a some kind of availability to host all the chat messages. Uh, but the way the APIs and DynamoDB are going to be designed is that we should be able to break it off into individual nodes, and nodes can choose whatever hardware they want to run on. And even though we're using DynamoDB, we're just going to use a single database approach, which uses the what is it called, the partition key and sort key style of storing lots of different entities on a single database table. That makes it easier for us to scale this out well, not scale this out, but like to break this out into SQLite as well. It's just a single table. We just have to change the client that talks to the where the data is, right? So let's just do a little bit of catch up on what I was doing off screen. One of them is basically using AWS Amplify to host the website, and we're using the standard API gateway to host our APIs, and it's using a lot of CDK stuff. While we're working on this stuff, and as we add a few more features to our infrastructure. We'll get a chance to kind of dig into that, but right now there's not a whole lot there. There's a stack for the APIs, there's a stack just for the database, there's one for the repository. This repository is the so the API gateway is backed by Lambda functions, and what I'm doing is, rather than using Lambda functions that are designed in a way to be deployed just on AWS, we're using Docker images, and we're using that to deploy our Lambda functions. This means that anyone that can build a Docker file can potentially run the same code. It's just one step, even though we're kind of coupled with AWS, we don't really have to be. That's just a step we don't have to deal with when we get there, but it's time to kind of make things a lot more decentralized. What else have I worked on? Yeah, I thought a little bit about what the database structure was going to be like, but we'll get to that as well. Now, let's talk about Firebase. Let me just switch over to a different browser. This one. Yeah, okay, cool. Okay, so I'm just running it locally right now, and let me just minimize all of these endpoints. So currently the application just has a standard hello world endpoint. If you just forget it out, it just responds back with hello world. I'll probably delete this, but it's okay. It just tells that it's still alive. It's responding, like it's a basic smoke test, right? So okay. So the two important endpoints related to authentication are register and login with the guest. So let me just kind of explain what that's really doing. So when you register, you want to be able to sign a message that says that provides enough information in the actual message about who you are. You're also sending over the public key and the signature after signing the message, just to kind of allow the backend to kind of verify who you are. So an example of that would be a message that is this one. Let me just generate a brand new account. So an example of that would be something like this. And once it's decoded, I'll just explain what's in the actual message. So let me just run this, and then I'm going to show you what the decoded message is supposed to look like. Alright. Actually, it's a lot easier if I just share my entire screen. That way I can just go back and forth between these. Okay. It's probably hard to see, but it's an object that has a signature, a signed message, and a public key. So let's go ahead and execute this. What this will do is it will basically go ahead and verify that you are who you say you are. It's in the account ID, and it will create an account on the smart contract. And the smart contract is right here. So just jump over to near blocks and then testnet. You take a look at that smart contract. It should have created a, yeah, I guess not. Okay, that's fine. So just making sure that your account, it should have created it, to be honest. Right, I forgot. It's actually the guest smart contract. That's the main smart contract, but the one that controls all the guests are over here. So it should have ran like just a minute ago. Okay, perfect. So this is the one. So let's open this. And let's just take a look at what's happening in here. So that's what it did. It registered the account and also registered the public key that came with this. It's just there so that in the future, if you want to sign a message, you can just pass your account ID, and we will basically get the public key that's already on the blockchain to verify. If that turns out to be too slow, then we can just store it in a database table somewhere. like once you create it, that public key is not going to change, and so that's fine. So the account is just this account doesn't actually exist anywhere, but it does exist in theory because Alice dash the timestamp can only exist on this particular contract. So what this means is that even though it doesn't exist right now, it can still act as if it exists, and we can take a liberty to do that because we own that the contract that the only contract that can actually create this address. And when it's time for the account to be created, we can just create it. Let's just say the person's been chatting, or they have to receive some funds, or for whatever reason, they decide to deposit some amount and create an account. Then we can just go ahead and create that. The next part is that now that we have a way to verify who the person is. What we're doing is the second endpoint, which is the login guest. It takes the same message, so I'm just going to go ahead and copy the message. I'm doing a lot of scrolling, just excuse that. It's probably dizzying on your end, but okay. So if I pass this message, what's happening is that we know that we can verify who the person is, and now that because we can verify who the person is, we're going to go ahead and create an account on Firebase. And not only that, we'll create a custom login token that's associated with the with this address. So the cool thing is, the reason why we're using Firebase is that you can create any ID. It doesn't necessarily force you to create an account that has email address format. So this works perfectly because you can put any arbitrary string in there and call that your ID. So what we're doing here is just saying, as a user, you can say this is who I am. That's the signature. That only I can sign this, and you can verify this that the contents are basically the address. Once it's verified, it's just going to go ahead and say, okay, I know who. Okay, I believe you. I know who you are, and here's the sign-in token. So what we're going to do here is just so this token can be used by any of the clients, and the client just needs to know how to talk to Firebase, and from there it can just generate. It can basically sign in with this token, and from that point onwards, you're going to get your standard. All of this access token and refresh token and all that standard stuff that's related to JWTs. However, I kind of think that because we have a way now to prove who the to kind of prove authenticity of the message, like who basically, if I sign a message that basically looks like this, and I'm passing my public key with it, there's a way to verify that it's coming exactly from me. So in theory, we don't really need a Firebase authentication mechanism to be part of the application. So you can just say, just sign the message and put the signed message and the account information is somewhere in the header, so that we can just use that as the authentication piece, right? So we can, let's just say we have a body and we're trying to create like a chat. Let me just go ahead and see what that looks like. It's basically, let's say this is what we're trying to create. So it has an ID. Well, ID is not being passed, so we don't really care about that. Let's just say the chat is a self. I'm just taking notes for myself, and that's kind of the chat what it is. Excuse the cough. Admins. It's just going to be me, which is this particular account, and that's an array. And then we're going to say participants. probably spelled that wrong, but that's not a concern right now. And then settings, there's really no settings, so just leave it as is. So we know that this is the object that we want to send, so we can probably minimize the JSON size like this, and we can sign this as the message, and you're going to end up getting a signature and the signed message, so which is basically a combination of the signature and also the actual contents of the message. So once you verify it, you can figure out what the actual contents are, and then you can use the contents as the payload, and the fact that you verified it means that it's a legitimate request. I don't really know how trustworthy that approach is, or how fast it's going to be, or how fast it's going to be, or whether the so I'm a little bit unsure. I think it's something we can use, but just because I'm not 100% sure, I'm just not going to go with this approach right now. So it's kind of where we are. We already have a CI/CD. Well, we don't have a CI/CD thing set up yet to deploy the API, but I have a couple of handy commands that just deploy the Docker instance and just basically deploy the stack. So anytime we make an update, we can just go ahead and push that out to AWS, test it out really quickly. We don't necessarily need to. We can always just run it on the local endpoint and test it out. Let's see. So kind of left off, kind of got to a point where I have the chat endpoint set up. They don't really do anything, so at this point it's really about the grunt work of setting up the database access to create all the records whenever a user does CRUD actions on the chat. Once that is done, we're going to start to do CRUD actions on the messages. So to simplify our life a little bit while building this stuff, I'm pretty sure I do want to just store the at least for the not the release, like it's not even close to release, but I do want to make sure that the messaging is working, that we do get messages back and forth. So what I'm going to do is the database is just going to store the in the chat object, it's going to store the messages, right? And the messages are going to just contain the plain text content of what it is, just to kind of make sure that we have that accomplished before we can start figuring out a way to before we can figure out a way to have a direct machine-to-machine communication. I think. Yeah. So I'm just gonna start working. I might be quiet a little bit, but I'll try to explain my thought process as I'm working on stuff. Okay, so let's do a create. So before we start actually adding the database, I'm just going to explain what I feel the database structure is going to look like. So for those who are not familiar with partition key and sort key, database on Dynamo is just going to look like this. Partition key, sort key. I do want to double check that I did create that database to support partition key. Oh, perfect. So it does have a partition key and sort key. That is good. Okay. So these are the two columns, and what we're going to do is also have the record, and that's just a JSON payload. Oops. That is the JSON payload. Why does it think it's TypeScript? Let's just make it like this. Yep. Okay. Now, um, if it is primarily a chat object, it's going to start like this, and then the ID is going to follow. Then we're going to have a message or settings, and then the object that contains the settings. Okay. And then if you want to have a chat ID, and we want to have a message ID. This is not going to be an ID. It's better if it's a KSU ID. It's basically a GUID, but it also has a time component associated with it. So all the messages are automatically going to be stored in the same order, in the order in which they were created, and then the record for that message. And that record is going to be similar to trying to find my models. That record is just going to be this. It's going to have an ID, sender ID, timestamp, the type of a message, it's a text or an audio or a file or a video, and then the context. Contents, if it's just plain text, it's always going to be here. Otherwise, it's going to be a path to the location of where that thing is stored. But I'll start with text from now, and then from there we can start with the other contents that are there. Next is the user ID, and then you can have chat ID. Right. So I'm also going to add one more thing, chat. Okay. So what's going on here? So let's say I want to get everything associated with this particular chat ID. What I can do is I can make a request to the database and say, get me everything that's in the partition key chat ID. So that's going to get me the settings, and it's going to say, get me all the messages. Or if I want to say, 1, 2, 3, 4. Okay, so let's say I want only the messages. I can basically say, get me everything that's in the partition key, and then in the sort key, get me everything that starts with message. And then I could also give it a query parameter that says, hey, get me the first 2 messages, or get me the last 2 messages, or whatever. That's still going to be fine. Now, what if I'm a user and I want to know what chat IDs that are associated with my account, right? Then I could just say, hey, I'm the user, get me everything where the sort key chart starts with chat for this particular user. Then it just populates all the chats that I have. Let's see. Or if you just have all the chats that can exist, they exist in this particular primary table with the partition key chats, and then you can say, okay, in a scenario where you just only care about the chats, you can just say, hey, get me everything where the chats are the primary key, and then the sorting key starts with chat and a hash, right? That's one way you can do that. In some cases, you will have duplicated data, and we don't really mind that, just because you have a very, very quick way of retrieving data, as long as you know exactly what it is, the object that you're looking for. So where are things going to be duplicated? So let's just say we have a chat 01. When we go ahead and do the CRUD actions, we have to run the CRUD action on both this record and this record at the same time. And the cool thing is, DynamoDB supports transactions, and SQLite also supports transactions. So we're not running transactions on, at least right now, we're not running transactions on large number of records. It's just going to be 1 or 2 records, just because it's I lost my train of thought because of the cough. Yeah, um, it's just we do duplicate it, but that's okay. It's going to be fine because we don't have a whole lot of records that are associated with the transaction on the database. So that's kind of the model that I'm going to go for. It works perfectly fine. This is in line with some of the suggestions on how to use DynamoDB. There's a couple of talks. It's really impressive how much data can go on a single table and still be performant with this approach. Right, so I feel like it's about 30-minute mark. I'm gonna start my stream. I'm gonna start it again in about 5-10 minutes just to kind of recompose. And what we're gonna do then is start with the CRUD actions and just start creating a simple way for data to be stored, retrieved, updated, listed, whatever we need to do.